Today we're going to talk about a specific type of probability distribution called a binomial probability distribution. Now, I want you to consider this situation. I have a die here, and I am going to roll this die 5 times. So I'm going to say that the number of times that I'm going to roll the die is 5. I am going to define a random variable, x, to be the number of 6s. The number of times that I roll the die out of those 5 that I get a 6. So if you think about it, I could possibly get all 6 6s. Or sorry, all 5 6s. All 5 times this could land on a 6. Or I could get 4 out of the 5, 0 out of the 5. The possible values of x then are, I could get 0 6s, I could get 1, I could get 2, 3, 4, or 5. Now, the key here, well, a couple keys so far. Number 1, I have a fixed number of trials in this situation. 5 trials. I'm going to roll the die 5 times. These are the possible outcomes of the random variable. Now, here's another key. Think about the probability on any one trial that this die will land on a 6. Well, the probability, of course, the probability of it landing on a 6 would be 1 out of 6. Okay, 1 good outcome, a 6 out of 6 total possible outcomes. So the probability is 1/6. So, and that's the same for each trial. Okay, so the probability of success, and I'm defining success here as rolling a 6, is the same on each trial. Okay, so I have a fixed number of trials. The probability of success is the same on each trial. Those are 2 requirements for a situation to be a binomial probability situation. Now, here's another thing. Successive trials here are independent. What happens on any one trial does not affect the probability of rolling a 6 or any other number on the next trial. So successive trials are independent. So I have a fixed number of trials. I have an equal probability of success on each of the trials. 3 successive trials are independent. I'm just going to write independent. And the other thing is, and this is pretty obvious, every trial can result either in a success, which I have arbitrarily defined as rolling a 6, or a failure, which is what happens if I roll any other number. Okay, so I've defined 6 as being a success, and anything else as being a failure. So the 4th thing I'm going to write up here is every trial, on every trial, you're either going to get a success or a failure. Those 4 conditions must be present in order to have a binomial random variable and to be able to create a probability distribution for this, in this case, binomial random variable. So I have a fixed number of trials, that's number 1. Number 2, the probability of success is the same for each trial. Number 3, successive trials are independent. And then number 4, every trial results in either a success or a failure. Now, here in a second, in the next video, we'll talk about how to compute binomial probabilities.